Hey class, welcome back. Mrs. Matheson here, and we are going to cover Unit 8, Notes 4 on rationalizing the denominator. So our learning target today is I can simplify radical expressions involving division and then rationalize the denominator. So that's something new we haven't talked about, we haven't heard about, is that rationalizing the denominator yet. So let's first talk about simplified form of a radical expression. So remember, radical expression is anything that has a square root in it, or a cube root, or any type of radical. So there are no perfect squares left underneath the radical, there are no fractions under the radical, and there are no radicals in the denominator. So think about denominator, that's the bottom half of the fraction. So we're going to first talk about just dividing radicals. We have our quotient property that says, hey, if I have something underneath my square root sign that is a fraction, such as this, I can actually break it into two parts. And the top and the bottom will have their own square roots. So let's go ahead and try that with our first one here. So first, I'm going to break it into the square root of 15 over the square root of 12. Okay, we're going to simplify underneath our radicals. And so 15, we're thinking breaks into 3 and 5. And then on the bottom, we have the 12, and that breaks into 3 and then 4, which is 2 and 2. Oops, not 3 and 3. There you go. One thing I do want to point out here is that if we have multiple things under a square root, we can actually think about breaking them apart. And these 2's, I'm going to put back into a 4. Because now we have a square root of 3 over square root of 3. These are going to cancel out. So we have square root of 5 over square root of 4. Well, are either of those a perfect square root? Well, the 4 is. So that's going to simplify us to square root of 5 over 2. So that's why we put this back into a nice perfect square. Okay, let's try number 2. So I'm going to break 21 down into 3 and 7. And then I have 27. And because I have a 3 and a 7 on the top, I'm going to look, does 3 or 7 go nicely into 27? Well, 3 and 9 do. So I'm going to leave it like that because my 3's are going to cancel. So I have square root of 7 over square root of 9. And that square root of 9 is a nice perfect square. So we get square root of 7 over 3. So looking at both of these examples here, we have, let's just make sure they're in simplest form. So there's no perfect squares left under the radical. Square root of 5, square root of 7, neither are perfect. We have no fractions underneath the radical. Nope, the radicals are just in the top. And then no radicals in the denominator. Our denominator is 2 and 3. So our fractions, our radicals, have become simplified. Okay, so radical, think about rational number. That's, you can write it as fraction. A rational number is anything that's non-repeating and non-terminating. So if you have a decimal that's like a nice one, or if you have a number that's a nice number, that's a rational number. So any whole numbers are rational numbers. Any nice fractions are rational numbers. Anything that gives you a funky decimal that is going to repeat or not repeat and run on forever, such as 1, 2, 5, or 4, 5, 1, 3, 2, so it doesn't repeat itself, it just goes on and rambles, kind of like number pi. Those are irrational numbers. So if you have a square root that is not a perfect square root, that's an irrational number, such as this funky decimal we have. So we can't have those, so we want them to become rational numbers, nice numbers. So that's why we call this rationalizing the denominator. So when you have a radical left in the denominator, remember that would be an irrational number, you must rationalize the denominator. And here's how you do it. Simplify the radical expression, so like we were doing on our last two problems. Then you multiply the top and bottom of the fraction by the radical. And it's the radical that's left in the bottom, or left in denominator. And then you're going to simplify again. So we simplify, we rationalize, we simplify. So it sounds kind of funny, but let's look at it. Okay, 1/3. Can I simplify anything there? Let's just think about it as square root of 1 over square root of 3. None of those are perfect, so none of those can be simplified. So step 2 says you're going to multiply by the top and the bottom by the radical that's in the denominator. So we're going to multiply by the square root of 3. We know that when we multiply radicals, we multiply the numbers underneath the radical symbol. So my top is going to turn into square root of 3, and 3 times 3 is going to give me square root of 9. And then step 3 says to simplify again. Square root of 3 is not going to simplify any, but the square root of 9 is going to turn into 3. So now we've simplified by rationalizing the denominator. All right, so go ahead and look at number 4. Let's see if we can simplify. Well, 12 over 10, we can simplify because you can divide both of those by 2. So we are going to get 6 over 5. So we simplified that, but let's break that into 2 parts, the top and the bottom. All right, so step 2, we're going to multiply the top and the bottom by the radical in the bottom. All right, so 6 times 5 turns into 30, and 5 times 5 turns into 25. Step 3 says to simplify again. Well, 30, let's think about that. Breaks into 5 and 6 breaks into 2 and 3. I don't have any duplicates, no pairs, so it's not going to break down any further. And then square root of 25 is going to turn into 5. Now, looking at this problem, some students will automatically go, oh, I'm going to take 30 and I'm going to divide it by 5. We can't do that because 30 is under a radical and 5 is not underneath the radical. So you can only simplify if they're both underneath the radicals. All right, so let's take a look here at 5. 3 and 10. I can't simplify this any further, but I can break it into square root of 10 over square root of 3. Okay, step 2 is we're going to multiply by the radical on the bottom. All right, so we get square root of 30 on top. 3 times 3 gives me 9. We just saw in the last problem that 30 does not break down. It seems like it should because it's such a big number, but it just doesn't. Square root of 9 turns into 3. Remember, we cannot take 30 and divide by 3. 30 is under the radical, 3 is not, so we're going to leave it as is. So nice work with that, guys. Okay, so we have problem 6 here. Problem 6 says 6 over 9. We can reduce that. We could do this actually 2 ways. So let's look at it. We could take it and break it into reduced, and we would, 6 and 9 both have 3 that go into it. So we would get a 2 on top and a 3 on bottom. We're going to multiply by the radical in the bottom. So 2 times 3 is going to give me square root of 6 on top. 3 times 3 is going to give me square root of 9 on bottom. We can simplify that square root of 9 into a 3. All right. Or, looking at this, there should be a little red flag that's going off in your head right now with that. Anybody see it? Anybody see it? It's a perfect square. So if we take it and just break it down, we're automatically at this step. So sometimes, watch the problem. It might actually have a nice perfect square root in it already and give you the same answer. So, like I said, 2 ways to do it. We have problems 7 and 8 here, and I want you to try out 7 and 8 for me. Try out 7 and 8, and then we will do problems 9 and 10 for sure in class. Ooh, 11 and 12. Those are definitely great questions for class. So 7 and 8 for sure. Try 9 and 10. We'll do 11 and 12 in class, and we will see you then.